Hello everyone. Today we will discuss about the dielectric properties of the materials. So the substances are broadly classified as the conductors, insulators or dielectrics depending upon their electrical properties. So basically the dielectrics are electric insulators which ordinarily do not contain any free charge carriers for conduction. But it is observed that when we fill the space between the plates of a capacitor with a dielectrics, the capacitance can be increases. So the capacitance of the capacitor, which is the with a dielectric in between the plates, is found to be some epsilon r times the capacitance with air as the intervening medium between these plates. So this epsilon r is called the dielectric constant. So dielectrics are basically insulators, but if you use these insulators in this kind of dielectric insulators in between the plates of a capacitor, it is found that the capacitance can be increased by a factor of dielectric constants. And the common values of the dielectric constants are we normally consider for air medium it is 1, which is for the free space as well, but for the glass the value is about 6, and for water it is 81. So we can say that these are the electric insulators which contains positive and negative charges but which are bound together and hence could not be affected by the applied electric field. So dielectrics contains positive and negative charges but which are bound together, so that we found that it is electrically insulator but which can affect by the application of electric field. Matter can be broadly classified as the polar and non-polar type of molecules. So in certain atoms, the atoms and molecules have equal number of electrons and protons in them, and in certain molecules the center of their positive and negative charges coincide. As a result, the net charge of the molecule becomes zero. Such molecules are said to be non-polar molecules, for example the oxygen, hydrogen, nitrogen, etc. In certain material molecules in which the center of positive and negative charges do not coincide, so they are called the polar type of molecules. So there is a net dipole moment in such materials. So those are the examples for the non-polar molecules are the water, H2O, HCl, CO, carbon monoxide, etc., which belongs to the polar type of molecules. So naturally, some molecules, some atoms, some molecules are non-polar type, where these positive and negative charges are coincide with each other. But whereas in certain molecules, these are separated. So those are called the polar molecules. So we just understood that each atom contains positive and negative charges, because the positive charge due to the nucleus and negative charge the contribution from the electrons. When these atoms are placed in an electric field, the both positive and negative regions will be influenced by this electric field. For example, the nucleus will be pushed in the direction of electric field and electron will be pushed in the opposite directions. And if the field is sufficiently strong, it can separate these two regions completely. So that is the ionizing or ionization of these atoms. But when we consider the weaker field, there is be an equilibrium state which result these two regions, the positive and negative charge regions, will be separated by a distance. So this is called a dipole. So in the positive and negative regions which are slightly separated by a distance which can still attract each other, and the atom is said to be polarized. So this form of this is an induced type of dipole because we applied electric field. So the dipole moment which is approximately which will be proportional to the electric field. So we induce the dipole here and the corresponding dipole moment is proportional to electric field. So that we can say that the polarized dipole moment is proportional to electric field, and corresponding corresponding constants is called the polarizability, atomic polarizability. So these are all the introduction to this chapter. Now we discuss about two type of molecules. One is the polar molecules, in which the center of the positive and negative charges are separated but have a permanent dipole moment. So when an external field is applied, the individual dipole moments tends to align with the field. So the sum of the dipole moments of all the molecules is taken. There will be a net dipole moment which is be in the direction of the external field. In the case of non-polar molecule, here also due to an external field, the positive and negative charges which are coincide with each other will be displaced in the opposite direction because due to this field. So this displacement when external forces on the charge of molecules is balanced by the restoring force due to the internal field in the molecules. Thus the non-polar molecules also develop an induced dipole moment. So we can see that in both type of molecules, whether the polar or non-polar, a dielectric develops a net dipole moment in the presence of the external field, and the dipole moment per unit volume is called the polarizations. So the polarization is nothing but the total dipole moment per unit volume, which is happening in both polar and non-polar molecules. And this polarization, which is denoted by capital P, which will be proportional to the external field. So this will be proportional to the external macroscopic field which we applied, and if you equate this one, P is equal to some epsilon times psi E times E, where epsilon naught is called the permittivity of free space and psi E is the electric susceptibility of the dielectric medium. So the electric susceptibility is the measure of the polarization produced in the material per unit resultant electric field. So we can define electric susceptibility as that. Let E0 be the external field applied to this particular material, and due to this polarization happening inside the material, there will be a polarizing field will be developed, which is called EP, which will be in opposite direction to that of the applied field, so that the resultant field E will be always less than E0, where E0 is the applied field, E is the resultant field. Now we need to define what is their local field. So the electric field acting at the site of an atom or molecule, the field responsible for the polarization of each atom or molecule of the solid. So for an atomic site with cubic symmetry, the localized field, which is called E local field, is equal to E plus P by 3 epsilon naught. So apart from the macroscopic field, the local field also contains a term which represents the field due to the polarization of other atoms in the solid. So this is the local field, which is the sum of the applied macroscopic applied field plus P by 3 epsilon naught, and this field, this term is due to the polarization of other atoms in the solid. In dielectric material, the electric displacement vector defines the response of the material on the application of electric field. So according to the Maxwell's equations, it appears that the electric displacement vector D is equal to that is epsilon E, that is epsilon is epsilon naught into epsilon R, where epsilon R is the relative permittivity of, or which is also called the dielectric constant of the material. So this is equal to epsilon E plus P. So this electric displacement vector can be expressed in terms of the polarization as well as the electric field. So from this equation we can define the dielectric constants, which is equal to epsilon E plus P divided by epsilon E, which is equal to 1 plus psi, that is the susceptibility. So this is based on the polarization. The expression for polarization is P is equal to epsilon naught chi E. So here we can it relates the dielectric constants with the susceptibility. So that means the dielectric constant is also a measure of the polarization of the material. So we have defined what is an induced dipole moment in the case of an atom, where the localized field which cause a displacement of charge inside the atoms. So there will be a displacement of positive and negative charges which will cause an induced dipole moment. So this induced dipole moment is proportional to local field E log, and this is equal to some proportionality constant alpha times E log. So this proportionality constant is defined as the polarizability. So polarizability we define in the case of an atom where the electric field, the local field, can induce dipole moment. We can say that the polarizability is an atomic property. Whereas the dielectric constants, which is a macroscopic property which depends on the arrangement of atoms within the crystal.